Should I look at you or into the camera?
Yeah. So we're at the Under the Radar conference, and it's a little noisy here because we're in the press room, you know.
People are leaving right now.
Hey,
the moment we start.
That's a good thing. So who are you?
I'm Emil Eifram, and I'm the CEO and co-founder of Neo Technology, which is a Swedish open source database company. The other Swedish open source database company, and we're the commercial backer of Neo4j, which is an open source graph database.
And so graph to me means like the social graph, like Facebook, like Twitter, who I'm following, who's following me, that kind of thing.
Exactly.
So is that what you're doing?
That's exactly what we're doing, except what you took was one example of a graph, which is the social graph, and there are many other examples of graphs. One example can be in finance, for example, in fraud detection. Then one node might be, a cash infusion place and a relationship. Actually, I can draw this if you want.
Yeah, please.
It's like you have a node which would be, cash infused by. Actually, this could be a guy. This could be like Robert Scoble, right?
Yeah.
And you infuse cash into this pizza place, and then at some later point, cash is traversing over here, flowing over here to some other place, and at the end of the day, it ends up with the mob, right? Yeah. And then we want to find a pattern. How did that cash end up with the mob? So that could be one example. Another example, which may be up your alley, is this could be a routing table. In terms of, this is a point of interest, you're at Microsoft campus in, where are we? In Mountain View?
Mountain View, Google's down the road.
Right, exactly. And these are the roads.
Computer History Museum's right down the street.
Exactly. And these are the roads, and they have properties saying, this is 13 miles to this place, and this is this place. And around here is, some restaurant, etc. And, I want to find all the restaurants within 30 miles.
Yeah.
Which is, and then you traverse the graph.
Yeah.
Now, the interesting thing about that is actually when you take and you overlay a social graph on that. So imagine that, this is actually you here, Robert Scoble.
Right.
And you want to find, and you have your social graph, and you have this is me, and, let's assume that we're friends.
I'm friends with everybody.
Yeah,
so
okay. Yes, that's a reasonable assumption. And then I've been to this restaurant and I like it, so I recommend this restaurant. So this is the knows relationship. Robert knows Emil.
Yep.
But this is the recommends. So I recommend this restaurant, right? So then you want to suddenly have a graph which has geographical information in it as well as the social graph. So you can ask a question such as, give me all the restaurants which are 30 miles from where I am that have been recommended by my friends.
Now this is interesting. Let's say there's 1,000 people here.
Yeah.
And some of them have, let's say this restaurant is a barbecue restaurant, right? And let's say some of them have been to more than 4 barbecue places in San Francisco area.
Right.
So let's say 100 of the 1,000.
Right.
Can I present only those 100 people's recommendations? Because I don't want to listen to people who haven't been to very many barbecue places.
See, so what you would do in that case is that you would actually do a multi-traversal, which is find all the restaurants within my near vicinity.
Yeah.
That's the first one. And then the second one, find all the restaurants that my friends have recommended that are within this area. So that's how you would do that. And you can even get more sophisticated and say that actually what I want is the restaurants that my friends have recommended, ranked by how, the weight they recommended it, as well as the friends of their friends.
Yeah. Well,
so
also in their experience, because if I go to 4 barbecue places, I'm not going to recommend all 4. But my act of going to 4 separate barbecue places has marked me as more credible on barbecue recommendations than anybody who has only gone to 1 or anybody who's gone to none.
Exactly, and that's an interesting point, because if you take that and take it to its logical conclusion, you end up with PageRank.
Yeah.
So you can, in a graph database, it's trivial to implement PageRank, which is Google's algorithm for how you vote by linking on the web, right?
Yeah.
And take that, but filter it through your social graph. So give me all the stuff that my friends have recommended, but weigh it by how credible they are, within that restaurant space, as well as the social graph. So the friends of my friends' recommendations will be less valuable than my close friends, but do that infinitely.
So if I want to build a new kind of restaurant recommendation engine or some sort of service that sits on top of a social graph, what choices do I have? I know Twitter has some sort of graph database, but it's not this complete, right?
No, exactly. So Twitter has just open sourced FlockDB, which is, they call it, I think, a social graph database, or maybe just a graph database. And it's excellent for Twitter's use cases. It's very specialized because Twitter has such an extreme environment, such extreme throughput and latency requirements. So they've narrowed it down. For example, they can only support one level of followers and followees, right? Which is the Twitter use case, which makes perfect sense. But what we have is we support infinite depth. So it's a more general purpose, and you can model things other than the social graph. For example, taking, this example with geo plus social, which I think that's a pretty cool thing to be able to overlay the social graph with the geo graph, and you can add, other graphs.
Well, and that's why I use that example. If I visit for barbecue restaurants, I've marked myself as credible, right? In Foursquare parlance, I get the badge, right? I got the barbecue badge.
Yeah.
Well, I only want to listen to people who've gotten the barbecue badge.
Who knows what the fuck they're talking about,
exactly.
right?
Exactly. Because, and you've seen this in Yelp. This is one problem with Yelp, right? My favorite sushi place has a few bad reviews because they were reviewed by people who don't like sushi and didn't find California rolls or all the Americanized sushi.
Right.
Well, an advanced sushi user doesn't care about that. They care about, is the sushi good?
Right.
The real sushi, the
and
real
I think,
fish.
Parts of that is, immaturity in the space, right? We have only been doing recommendation algorithms and things like that for this long, right? But I think it's also interesting to note that a lot of these kinds of sophisticated reasoning and queries and intelligent stuff is all about how are things related to one another.
Yeah.
And that's really where a graph database excels. Whenever the value is in the connections between things, then a graph database rocks.
Now, another problem with choosing a database, this is going to live at the center of my system, and I'm probably not going to build them in Twitter, but somebody will, right? Somebody will build something that'll get, 20 million visits a month, like Chat Roulette or something, something crazy will come out. So how scalable is your database, and how does that handle scale? Can I, split it up among a bunch of cloud servers, or tell me a little bit?
Right. Yeah. So I mean, one big part of NoSQL or part of the NoSQL movement is horizontally partitionable, horizontally scalable, right? Yeah. And the interesting thing about that is that it's all about taking parts of your data set which is not connected and then putting that on one machine. Now, a graph is the most generic data structure, and it's all about connecting things. So it becomes really challenging to scale that out horizontally. What we support now is that we scale to 12 billion nodes and relationships, which keeps most use. I mean, that's a pretty high bar. And we scale out using replication, which means that basically the full data set is replicated to a bunch of slave machines. So if one shuts down, then you have the others, and you can scale out reads on that. And that takes most people, to the end goal. Now, what we're working on is doing transparent partitioning of this, which is a non-trivial CS problem, which is all about figuring out that, for example, in this graph, you see that this is a tight cluster like this, and then take this part, put that on one machine. Whereas this guy, he might then be connected to many other things here, but there's only one connection between here. So then put this on a separate machine. The problem, of course, with that is in a graph, since a graph is such a flexible data model, you can, of course, after a while, someone comes in and creates a relationship. This guy likes this guy now, or whatever, this restaurant, or becomes friend. And then you need to reshuffle that behind the scenes. So that's clearly, I mean, it's non-trivial, but that's what we're working on for Neo4j 2.0.
Very cool. What's your business like? How do you make money? Do I pay for this? What if I want to build a new service?
So we're open source, which means that we're open source, and it's the AGPL is the license that we use, AGPL, and the AGPL is kind of interesting in that it is sort of like the GPL, but it's upgraded to the new century. Are you familiar with the GPL? Mm-hmm. Yeah, so it's a reciprocal license, which means that if you're open source, I'm open source. The difference between the AGPL and the GPL is that the AGPL also works behind firewalls. So the classic case is that Google has a bunch of MySQL servers, right, that they don't have to pay for because they never ship binaries to someone. They just deliver it over the web. And the AGPL closes that loophole. So at the end of the day, if you want to develop your new service as open source, we're open source. You don't have to pay us a dime. If you're not, if you want to develop closed source software, then you must buy a commercial license.
Okay,
So that's how we make money.
very cool. And how are you guys funded? And
We just raised a seed round, I guess 6 months ago now, so end of October, from two Scandinavian investors, Sunstone Capital and Connor Venture Partners. End of October, $2.5 million, and there's that.
that's pretty good.
Yeah, that's awesome.
Congratulations on that.
Thank you.
Where do we learn more about you? And by the way, what does your shirt say?
It of course says
persistent.
be persistent. I mean,
Yeah.
obviously. So neo4j.org
All right.
is where you find out more. This is your one-stop destination for everything graphs.
Yeah.
Anything graphs.
Are you on Twitter too?
I am on
What
Twitter.
about your personal Twitter address?
So this is Neo4j's Twitter, and my name is Emil Eifred. You should follow me on Twitter.
I should. I'm going to do that right now.
You actually already are.
Oh, see, I figured that out. It's pretty rare that I
Comes
find
back
a-
again to the fact that you're friends with everyone. Yeah.
Yeah, it's pretty rare that I find a geek that I'm not.
That you know,
following.
yeah, that's how
So
it goes.
thank you very much. This
Thanks,
is really,
thanks a
really
lot.
cool. Yeah,
Appreciate
thanks.
it. Thanks.